I was gonna.
Can you maybe outline it
for
for us?
modification when I'm done today, because I don't know how far I'm yet.
Okay.
And can I? I'm sorry. Can I?
Just outline it for us. So,
Yes,
is
I
it
can.
all in class or is it?
Yes, it is.
It is. Okay.
So, chapters 2 and 3.
I'm sorry, you guys. I apologize.
Chapter 4. Think of chapter 4 as a more interesting part of the exam. A lot of chapter 2 and 3 is just crunching, getting the math D business out of the way. So maybe you should focus more on the higher level of chapters 2 and 3. Know your definitions. Remember, Brad, I think you were the one who had me yesterday in class just throwing on the board a lot of definitions.
Yeah, well, we did that on Saturday.
It was a Saturday.
Which I have that posted online too, if anybody needs it. But so maybe more so just go through chapter 4 because there's a lot of matrices and determinants in chapter 4 worked into these problems, so we get our practice doing that.
That's true.
Right. Yeah, okay.
I agree.
And like last time, you told us to work on chapter 1.12 for review for the last exam. What would you suggest us work on?
You could dive into 2.9 and 3.5 as well.
And so we should expect our matrices to come in the form of sigma proofs. Generally, like we've been quizzed on for the past few weeks. Matrices, determinants.
Well, I wouldn't say the matrix automatically involves a sum. I think you're thinking of when you multiply.
Yes. Yes.
Yes. Okay.
But I mean, would you actually give us a matrix and just say reduce this to row echelon form? Or something like that. I mean,
Probably not.
you don't want to grade.
Unless I put a nice
you don't want
spin.
to grade something like that, right?
Unless I put a nice spin on it.
All right.
Yeah, I don't expect to answer math D questions.
Okay. Math D again. Like, what do you teach in math? I didn't even take matrices in math D.
Matrices in math D?
Yeah, we didn't even do matrices, but I took it in the summer, so.
Yes, you know what? You're right. You're right.
That was college algebra. We got introduced to that. Yeah.
Did you start from college algebra?
I started not this summer, but last summer I took math D. Yeah.
So you've taken like every math class offered here so far.
Yeah, and I took the fast track through all of them, and now I'm here in a year. Which is, like, yeah, I'm insane at this point.
Kudos.
Caught up to me. Started out.
Yeah. Started out with arithmetic review, and then no, I didn't. I'm joking. I didn't start that low, but
Do they really have that?
they have that here. You learn how to add and subtract. Yeah.
Well, I guess it makes sense.
Yeah.
Math is key to those.
That'd be killer, like, just, like,
It's like the ultimate
amount,
self-made.
like, the volume of problems, just doing all that.
That's all I've been doing for the past year.
So you guys, have we taken a look at these exams or not?
I haven't.
No. We haven't.
Can I erase this stuff off the board?
Exam 2.
Mr. Balga, can I erase this stuff off the board so I can see this?
One is the one from the wrong section.
Yeah. The first one.
Yeah, you know what? Somebody showed me this morning. You guys, here's what happened. I know you're used to having textbooks change editions, and it's basically not a good change at all. It's just to make money. The change in edition of this book in the second and third, there's a huge dramatic change, a huge shift in terms of how things are taught. And so it turns out that this exam is so old, 2004, that it was under the old edition, and apparently I was solving higher order PEs that you and I have not gotten to yet. So certainly question number 1 is not perfect for us.
Or 2.
Sorry, not 2 either. Ooh. But this was really slick. I can use determinants to help solve this one. Really nice.
But you're not going to ask us that, right?
I guess not.
It's not in the chapters.
Something else is going on. I don't know if it's a font in an old version of my equation editor, or if it's actually one of the Microsoft products. But some of these rectangles are showing that there should be, that in this case should be real numbers.
So just NAR.
Yeah, just an R. That's a good question. Can I look at it for a minute?
Subspace.
Oh, that is such a cool question.
What's C? Is that just a function?
Well, this set of all functions that are continuous over some interval line. And here's a collection of functions that up to whose first derivatives are continuous over on.
So,
I thought of a good question now. Are you guys able to just glance at it and answer?
Yeah, isn't it constants?
Yeah, very nice.
yeah.
Very good.
Did it say it? Prime goes equal 0?
Yeah.
Yeah, that's all constants.
So do you think this one's closed under addition? No, what about the scale of multiplication?
No.
Definitely not. What do you think?
When I did it earlier, there's
Do you think it's closed?
We'd have to,
Your zero vector is gonna be 1 over
I'd
A.
have to try it out.
Oh, hold it, everybody. I'm not reading my own question. I thought it was if I'm closed under addition or scale multiplication. I didn't see down below. Determine if the vectors satisfy those axioms. My apologies.
A6 is inverse, right? Not inverse.
Yeah, A5 is 0 element.
0.
Don't memorize these. I'll give you a sheet with them.
So,
A6 is
say it isn't closed under scalar multiplication and addition, do we even go on to the axioms after that?
If you're trying to figure out if it's vector space, no, you don't.
Yeah.
If one of them failed above. I didn't ask you if it's vector space. I said, specifically attack these specific axioms.
Okay.
So do you think A5 satisfies? Yeah, I think it is. As a matter of fact, I think you guys can probably relax and tell me exactly what the zero element is. What is zero element?
Just 4 zeros?
No.
Say it again.
0, or a set of, or 0, comma 0, comma 0, comma
Say
0.
it one more time.
0, 0, 0, 1.
Maybe just
I
0?
still can't hear you.
Just 0?
0 x squared.
0x.
It's not, it has to take the form of the original.
Was that a guess?
No, I do.
Okay, all right.
Oh, because it has to equal A, or because it has to equal the same thing, so it has to be 1. It has to be 1, right?
Do you see it?
Yes,
I don't see it.
You don't see it?
kind of.
Jason, do this. Watch. The zero element has to have this quality. That when I add it to p bar, I'm going to get p bar right back. But that means I'm adding to p bar, namely something like this. Try to look at my notation. When I add this to my z bar, my 0 bar, which is question mark times x squared plus pound symbol times x plus percent symbol, and I need to find out what those symbols are. I end up getting a sub 1 plus question mark times x squared plus a sub 2 plus pound symbol times x plus a sub 3 plus plus nothing. It's really times percent symbol. And I want this to be, in the end, a sub 1 x squared plus a sub 2x plus my a sub 3 sub
Why wouldn't it be a sub 3 plus percent symbol?
It's defined as multiplication of the problem.
It's defined as multiple. Oh, okay, I see.
So question,
Okay.
what must a coefficient of x squared be so that this is equal to this?
0.
0.
Okay.
Coefficient of x has to be
0.
0, but the percent symbol
1.
has to be
1.
positive 1 to get my a3 right back. That's why 0 bar is equal to that.
So wouldn't if you're writing that, wouldn't it be 0, comma 0, comma 1?
No, because these are polynomials. These are elements of P2. And you're giving me elements of R2. Excuse me, you're giving me elements of R3.
Oh no,
Why you giving me
I
all
just
those
didn't look at it. I didn't look at it correctly. I see what you mean. Yeah, I see what you
You
mean.
guys, can I change the question? I don't like it.
Okay.
Instead of telling me that the A6 is met, answer this question. if an element of my set has an additive inverse, what does it look like? For a given p bar, what does negative p bar look like?
One over.
Negative a1.
Times x squared.
Thank you.
Minus x plus 1 over a3.
Very nice.
I did this earlier.
So, yeah. So question, does every element p bar have a corresponding additive inverse?
Yes.
Mhm.
We don't know.
A3.
Yeah, if a sub 3 is equal to 0, I don't have an additive inverse. So I think a10, excuse me, a6 for that reason is not being satisfied. You guys, I'm being honest, I don't quite know if I remember what a10 is. I think it's this one. A10 is...
Yes, that's A10. Yeah.
Do you think that actually is being
Ooh, wait. No, that's not A10. That's not A10.
R plus S.
Yeah,
My
it's,
apologies, my
Equals
apologies.
RB plus R.
Daniel, I'm sorry, I wasn't listening.
It's R plus S in parentheses.
Yeah.
Times vector v. Equals R times
P bar plus S times P bar.
Yeah.
Or V bars, whatever you want to call them.
Distributed.
So do you mind if we don't go through that one? Clearly satisfied.
If you were to show it was satisfied, would you want us to use the general form?
No, I'd say, I want you to do neither one because it's definitely wrong. It's not satisfied, is it? It's the last term.
there's no way, no.
It's the last term gets goofed up.
Yeah.
If I take a peek at the left-hand side, R plus S, times my P bar, isn't that just simply going to give me an R plus S times A1x squared plus R plus S times A2x, and then finally, plus my A301. But if I were to check out what happens when I look at RP bar plus SP bar, I think that gives me the following. It's just going to be an RA1x squared plus RA2x plus my A3 plus my SA1x squared plus SA2x plus A3. Now if I add these two together, I think it gives me this. I can't hear you. I heard that. And they're not the same. Did you see it?
Yes.
Oy, oy, oy. Okay, everybody. I think it's determine a basis for the subspace of R3 consisting of all vectors in R3 satisfying that particular condition. And I apologize, I use the word basis. Change it for a minute. Change it to a spanning set. And you'll be able to answer it.
So is basis just another word for a spanning set?
Well, it's another word for an efficient spanning set. A spanning set
Okay.
that's linearly independent. So I think my space S can be spanned by the set consisting of elements of really?
X1 minus
Say it again.
X1, X2, and X3?
It would be 5 comma
Oh. What?
1 comma. Am I in the right room?
No, this is the wrong room. You're teaching an English class here. I don't know what you're doing.
Negative 2, 0, 1. Use a calculator. The darn desert island thing again.
Bloody
Oh, you're
faced
getting the
calculator.
Can you show me your steps?
If you insist.
Oh.
I see it. So in that equation, okay, you guys, I really can't read it. You just tell me what it is. Isolate x1 on the left-hand side.
Let's get this 2 and this is 2 minus 3.
Is that it? And if we let x sub 2 being equal to s and x sub 3 to be equal to t, then I think correspondingly x sub 1 is equal to 5s minus 2t. So, it is the case that my set s is nothing more than the collection of ordered triplets x sub 1, x sub 2, x sub 3, such that both s and t range over the entire reals. But this is nothing more than a linear combination of 5, 1, 0, and negative 2, 0, 1, such that s and t range over the reals. But this is nothing more than the span of the set. Is this what I have on the board over there in the middle board? I hope so. So it's just doing it in your head. Thank you.
There is one that we went over really quickly. I think it was 2 problems back that he said something like it's constants or something.
Yes.
Can you just look
Okay.
at that really quick?
Can I erase this first? Can you guys just give me a little feedback, please? I mean, looking at this exam, so far, is it really simple? You want to think about it, or is this killing you?
Yeah, think
Show me your
about it.
thumbs.
It's like between top and.
Okay.
Yeah, I was itchy.
So we are all over the place. So, you said go back to something about constants.
Yeah, that
That,
one. Number 3.
now you guys keep in mind, shoot. You know what? I made a mistake. When I said that was a really good question, I meant describe us would be a really good question. I think the question I asked is a little too easy. So can I ask a different one, then I'll answer this one. Describe that vector space. What is it? Describe it in words. Well, it's a set of all continuous functions whose first derivatives are all equal to 0. What functions have their first derivatives all equal to 0? All the constant
Constants.
functions. Or how about this? I think S is just nothing more than real numbers. It's just R. So, but to show that it is closed under addition doesn't require me knowing that. To show closure for addition, let's just consider 2 elements F and G that are in S. And also, let's let how about K be equal to F plus G? To determine whether or not K claims membership to my set, look at the price to pay for membership. Let's check to see if the first derivative for K, with respect to X, is equal to 0. Check it. I'll simply come in and give K's old name right back. I think K's old name is this. But to differentiate the sum of 2 functions is the sum of their individual derivatives. But since both F and G claim membership to S, certainly the derivatives are both equal to 0. But 0 plus 0 is equal to 0. I've shown closure for addition. Scalar multiplication will be shown in a similar way. Is that all I have to show is those 2 things?
To show that it's a substitute.
Correct.
Yeah, well,
Well, no, there's one more thing to show, namely,
That's contains 0 is not.
there's something in there that it's not in. And certainly using the 0 vector will work. Not that you have to. Daniel, is that too fast?
No, so to use a 0 vector, you would just say.
Yeah, you can just say 0 is in there, therefore it's not. So determine if this set is closed under addition. You know what, you guys? Okay, that's a good enough question. I like that.
Second degree.
What do you think the answer is? Oh, by the way, this is okay for you guys, even though second order. This is a very pertinent question.
Yeah.
What's the answer?
Don't know yet.
Y1
Have to try it out.
prime
I
plus
say no
Y2
because it's not homogeneous.
What's that?
I say no because it's not homogeneous usually.
I like that, yes. Michael?
If we were to solve this one, would this be the one where we set like y, like for the addition one, it would be y3 is equal to 1, y1 plus y2, and then sub those into the y.
Yes, that's exactly what I need you to show. Yes. And if you go through all that work, does it end up working? Does it end up being the case that y3 is the solution to the DE?
Yes.
See, I think the answer is no. I'll show you. Because I think if y1, y2 are in that set as and y3 is equal to y1 plus y2, then when I take a peek at y through sub 3 double prime, is that minus?
Minus 2y.
Minus 2y prime. Here's what I get. Y3 is the original length right here. And yet again, it's the original length. It's just that you and I understand differentiation distributes over addition, or shall I say the derivative of the sum of two functions is the sum of their individual derivatives. We also have working for us in the real numbers system the law of distribution over addition.
It should
And-
be, it should be a prime in this second, the second term should be 2.
Oh, should it? Thank you. I see it now. Yeah, thanks. And here too, with distribution, I've got this. And now interchanging the second and third terms. Ah, but shoot, y sub 1 was understood to be claiming membership to my set S, and so another name for this is sin x. Another name for the second collection of terms is, but that gives me this, which is not equal to this. Oh, sorry, I didn't mean that. I meant it's not equal to this. Therefore, I do not have closure for addition. So now you guys see it?
Yeah,
Yeah.
it's not bad.
Do the real numbers form a vector space over the complex numbers?
So is that in our field?
Yes.
Yes. Why not?
Because a complex number one scalar multiplied by your real, gives you a complex.
Well, there's nothing wrong with that,
it's
because
no-
3 times 7 is 21, it's still a real number.
What about like 3 times 7 pi?
That's better.
Yeah.
So what you're really saying is taking a non-real complex number times a real number, you're gonna get a non-real complex number. I think what you should do in test situations is show me that counterexample. I think you should write something like this. Do you guys agree?
Yes.
And do you agree that what's by writing on the inboard being very clear to the reader? So really, really groggy late at night grading exams, you want to be very clear to them.
So is this about the length of an exam we can expect? Or was this from like a longer class?
Let me answer that question.
Okay.
Michael?
Okay, so for our number 7, so the reason why it's, I guess, non-remembered is because we set our V was in the real numbers and not the complex?
Correct. So I was assuming I said B was the reals.
Okay.
So if the question was switched and it was, do the complex numbers form a vector space over the
Now
real
your
numbers?
answer is
Yes.
good. I agree. Can I make room?
You're gonna put some extra credit on this?
Extra credits?
Because your extra credit problems are always awesome, and this would be a really great thing that you could probably find something cool for extra credit, right? Yeah.
That's very happy.
You guys, this question's okay. okay for you? I just worded it differently. When I talk about the components, all I'm saying is this, just like the homework we went over today, can you express x squared minus x plus 2 as a linear combination of the terms in a spanning set? That's really what the question is. I would, of course, reword it that way, since you and I haven't talked about bases yet, but you can answer the question. That would be unfair at this point, because I haven't talked about linear dependency. Well, I mentioned it in class last time, but I only mentioned it as you and I were walking out. We haven't really done an example. Oh, I love these questions. Well, not number 11. That's horrible. So, how would you answer the question of number 5, number 10?
Calculate the, write the formula for the determinant, right? And set it equal to 5. So it'd be c squared minus 2c equals 5, and then solve for c.
Just a math question, isn't it?
It's math D, yeah, math A even.
Yeah, sure, it's math. Oh, is that it?
C equals square root of 5 minus 2c.
So you wouldn't put 11 up there.
I wouldn't put a what?
11.
It's not hard, it's just time consuming.
I can't believe I asked that question. No, I'm serious. I was in a really, really good mood or something. Can you answer?
5 plus 2, so that all that makes 7 minus 2.
Is AB defined?
A, B defined.
Yeah, number of rows, number of columns the second is the same as number of rows the first. Is part 2 BA defined?
No.
No, because the number of columns of the first is 3, but the number of rows of the second is 2. What's the answer to number for part 3?
Yeah, you can't do it.
Yeah, addition's not defined.
Yeah.
What about part 4?
Reverse A.
Augment
Yeah.
the A with the
Yeah.
appropriate size identity matrix, and completely reduce the left-hand side to the identity matrix. Or the adjoint method, or just write the answer using our shortcut, yeah. I like that. Oh, there's only one exam too.
These are questions on that exam one from this unit.
I didn't see none of the other one.
I don't think so. No.
So far the answer is no. Let me check this one. I guess that's no.
So is the exam going to be comparable in difficulty to this one? Or?
I think this one that you just looked at was kind of light.
But lengthwise, is that about what we can expect?
Yeah, I think so.
Okay.
Well, yeah, but you have no idea how long this one is.
How long this one is?
Yeah.
Well, because,
Because you have to solve these different equations.
yeah, these
And those
DEs
DEs would say take a little bit of time.
take a little bit of time. All right.
Take that back. Number one's not that bad if you jump into higher dimensional space. Look at the complex side functions. Which we will do this semester. We will. Jeepers, you guys, I feel bad. I don't feel like there's very much on there.
Are we covering 4-6 tomorrow?
4-6 today.
Today?
Yeah.
Do we cover anything on that?
What's that?
Have we gotten to anything on 4, 5, and 4, 6?
No, 4, 5, and 4, 6 are what I was going to cover today.
Okay.
10 minutes.
Total of 10 minutes.
I just try to get through one example. I'll stop. Just one, please. Do you guys remember my definition of linear dependence or independence from yesterday?
Yes.
I got a better idea. I won't go through one example. That'd be a good one. I'll go through some really small, light examples.
So we should probably do 4.4 and 4.5, or 4.5 and 4.6 for.
No, as of now, I gotta take off the exam. The exam only covers up to 4.4. I gotta give you guys more examples. I can't do them 10 minutes. I only make this example up off the top of my head, you guys, because I know I've asked this on an exam in the past.
So linearly independent means again.
Well, there's a couple ways of saying it.
Okay.
You could treat this as saying the following, that one element set cannot be expressed as linear combination together. By the way, it's a poor question. I should have asked, is a set linearly independent or dependent? That's what I should have asked. Oh, you guys. The answer's supposed to roll right off your tongue.
Because given if you use a couple negatives or something like that, the hyperbolic cosine and the hyperbolic sine are very, very similar.
Cosine hyperbolic square, cosine hyperbolic
Say
square
what?
is 1.
Say one more.
Yes,
Minus.
Good. Since it's the case that hyperbolic cosine squared of t minus hyperbolic sine squared of t is equal to 1, that set is definitely dependent. Dependent. Dependent, not independent. Right?
yes.
Dang, that's a good question. And since you're stalling, I'm still upset I put it on the board. Could use that one.
So there's no trig identity I should be looking at here, right? Because we haven't learned
No, it's more your knowledge of trigonometry.
knowledge.
Your vast, expert knowledge.
Expert, yeah. No, it's
Daniel.
linearly independent.
Yeah, no, because you should be able to express sine inverse or cosine inverse as the other, and then with some relationship of power over 2.
Okay, then I retract a question. New question. If it is linearly dependent, show me what that relationship is.
Yeah, what is it?
Sine inverse t is cosine inverse t plus power over 2.
You're so close.
45 degrees equals t.
Well,
Or not 45 degrees.
1, 2, 0.
Well, no, because we need to put it in radians, so we need it to equal. Because if it's pi over 2 plus pi over 2, it equals pi over, or pi over 4 plus pi over 4 equals pi over 2. So the cosine and sine of root t over 2, root 2 over 2 for t, and it'll make them dependent.
well, look at my picture. What can you possibly say about the sine of theta? B over C. What can you possibly say about the cosine of theta? So you can think of phi as the I misspoke, sorry. You can think of theta as the inverse sine of B over C. But you can also think of phi as the inverse cosine of B over C. And that being the case, what can you say about phi plus theta? I have. But another name for phi is this. Another name for theta is this. Okay, so replace B over C with T. Same thing as
What if you just replace t with root 2 over 2?
T t was root 2 over 2.
Right? Wouldn't that make it pi over 4?
But you know, I'm asking if they can be expressed in linear combinations as functions of t.
As functions
So
of t.
not just
okay.
simply at one particular case.
Okay.
Yikes. Can I think of another thinking question really fast?
Yes, because if you added the two together, it's going to equal natural log of AB.
Oh, so you're saying no?
Huh?
It's just linearly dependent.
Oh, yeah, they're dependent, yes.
I forgot that. Oh, by now. You feel better writing today? Because I hate that thing that I wasted today.
No, that wasn't a waste at all.
I'm good.
Made our test easier because this looks pretty easy.
You know what, you guys? I just ruined the fun for you.
Yeah.
I'm gonna try to take a minute, if I got a few minutes, and just find another test I can post. How's that?
Okay.
So if we can stop class now, and I'll take care of that.